Hannover Messe. I'm Esther Lee, a product marketer for NVIDIA Metropolis, a development platform for vision AI agents and applications. And I'm so excited to be here today to talk to you about boosting your industrial productivity with visual AI agents at the edge. So thanks for coming this morning to learn more about AI agents. With over 10 million factories, there are nearly 500 million employees working 24/7 as a part of a $50 trillion manufacturing industry. And everyone strives to produce high-quality products that are made cost efficiently as well as quickly. Yet up to 40 cents on the dollar is spent in manufacturing that is lost on defects, it's lost on production errors, worker injuries, inventory displacement, and it often adds up to around $12 trillion of economic waste. At the same time, manufacturers are dealing with labor shortages. So for every 100% of jobs, 50% of those jobs go unfilled. At the same time, there's high turnover, and there is a rising skills gap that is happening. Many of our subject matter experts are retiring, and there's a rise in training costs. So on average, it's around $1,200 to train an employee, and that cost is only rising through the years. So to address these challenges, manufacturers are turning to agentic AI. And these systems will operate autonomously, pursuing complex goals and executing different tasks with minimal human supervision. They are using AI to make dynamic decisions by planning, figuring out the tools to use, as well as utilizing a variety of different capabilities such as camera feeds, sensor feeds, and using semantic search, visual Q&A, and the ability to using generative AI to develop reports as well as summaries. So where can you find these different industrial AI agents? This is what I call the mini, micro, and macro. So say that 3 times fast at 9:30 in the morning. So we've got at the left-hand side, we have mini AI agents. So these are very familiar to many of you. They're your visual AI agents. They're often looking for defects in your products, and they are often being deployed for very small, minute tasks. At the micro level, we have operator co-pilots. These are AI agents that are helping and assist your operators, whether that's in assembly, whether that's looking at worker safety needs, and other standard operating procedures that you might have within a manufacturing facility. And at the macro level, you've got mega-sized agents, which are actually an aggregate of multiple agents working together to automate an entire facility. It's helping to coordinate all the activities with your robots, your workers together in a harmonious way to provide an autonomous factory or an autonomous smart space. And so there are many different types of benefits that you can enjoy with AI agents. They help to increase productivity. They help to reduce the waste that we had mentioned briefly. They can also help to boost asset management effectively by understanding where the various pieces of inventory are within your warehouse. It also helps to reduce labor costs and prevent accidents and production problems. So when creating these different types of AI agents, NVIDIA's vision is really the usage of 3 different types of computers. At the bottom, you'll see here, there's a computer that's where you actually run and deploy your AI agents. They might be as visual AI agents, as we're discussing. They may be as a human robot. They may be within autonomous vehicles or as an entire factory and smart space. But if you move clockwise, these agents may or may not need fine-tuning. So if you need fine-tuning to make it more adhere to your business case, then you would actually train that with some of our frameworks such as Nemo and Tau. And at certain cases, some customers may actually not have enough data to do that training, and so you might need to simulate or synthetically generate more data in order to fine-tune the models that you need for your AI agents. And so NVIDIA Metropolis is a toolkit that helps to pull together all of the models, the microservices that you need in order to ingest your visual data, whether that's videos or images. And it also has the synthetic data generation models or tools such as Omniverse and Cosmos. So now we'll dive into each of the different types of agents. So at the mini level, we've got visual inspection agents. So historically, a lot of challenges that you might have on the visual inspection side is the low accuracy that might be seen with traditional CNN types of models. You might also be able to you're unable to discover new issues because it's more rules-based, and there also may be a lack of training data because you might be looking for defects for products that are brand new. So we have created a Metropolis visual inspection agent workflow where it utilizes synthetic data generation, utilizing a model called StyleGAN XL or Cosmos. And we have leading foundation models or vision language models that are optimized for performance so that you can reach the highest level possible. So one example that I'll run you through is a visual inspection agent for metal surface detection of defects. So on the left-hand side, you can see this is a real image data set. There's 6 classes, 25 images each. They might show scratches or different patches that have happened to the metal surface. And we're going to actually take those 125 images. You're going to use a model called StyleGAN. And from there, it's able to generate thousands of images to tens of thousands of images, whatever is really necessary for you to reach the accuracy numbers that you're looking for. And then once you have that additional data generated from just a small set of real images, you can then fine-tune one of your classification models, a detection model, and utilize it, combine it with an embeddings model, such as NVIDIA 2, and fine-tune that with a toolkit like Tau. And then when you run it, what we've been able to achieve is to move from an accuracy rate of about 89% with just 50 real images to now almost 99% with the additional SDG that was generated. So at the micro level, you've actually got operations co-pilots. So in this case, there have been a variety of different issues that might have, or challenges that you might face when building these micro level types of co-pilots, because you have to integrate a variety of different AI models. You have to figure out the piping in order to ingest the video, whether that's real-time or recorded videos. And lastly, you might have to optimize the models in order to ingest the content efficiently, as well as process all of that information in the best fashion. So what we have is a Metropolis AI blueprint for video search and summarization. It's a sample architecture for building these visual AI agents or operations co-pilots. It also offers fine-tuning. So if you need to, many of these models actually have high understanding just out of the box, but maybe there are specific processes that are unique to your business, and so you can actually fine-tune those to understand each of those nuances. So the blueprint is really focused on 3 main tasks. It can do alerts if you're looking for certain anomalies or defects. It can summarize all of that data, whether you have 30 seconds worth of video or 2 hours or 24 hours of data, and it's actually able to process that 60 times faster than real time. So what that means is if you have 60 minutes of video, you'll actually get a summary in just 1 minute. So it's an incredible acceleration in terms of the speed at which you can get insights out of the videos or the images that you have. They're just simple API calls. It comes built with a video ingestion pipeline, and as mentioned before, you can customize that according to what you need, both on the model side as well as on the deployment side. So you can deploy that in the cloud on AWS, you could deploy that on-prem or at the edge. So here's a brief overview of what is kind of art of the possible. So here you'll see a maintenance guy, and that was looking at different safety. Here is in a warehouse, and we're looking to see if there's any obstructions or spills in the aisles. In this case, this is also workplace safety. What the agent will actually notice is an individual walking through with the lack of PPE, so there's no helmet or vest. In this scenario, it's really about supply chain, asset management, inventory management. You see a pallet there, and how do we actually use 3D understanding to show where's the best place to actually place that pallet. So there were 3 different areas. This is for optical inspection. Traditionally, it was using traditional CV models. In this case, it's actually using, I'm just gonna, stop that for a brief second. So in that case, it was using a vision language model, and so not only was it able to classify what the defect was, but it was also able to define and provide more insights into exactly what the defect was. And in this case, this is a specific process. So there are 11 steps to assembling this server. You can put in different fans, and then there were 2 battery packs, and you can actually train the model to understand each of those steps and identify when an operator may have missed a step or performed it incorrectly to avoid further defects down the line. So 2 examples of how these agents are used at the process level. One is with Pegatron. So they're a printed circuit board manufacturer. They assemble many of these expensive printed circuit boards, and what they were doing is this little assembly process of analyzing how to integrate all of the cables on that board. So it's a very nuanced activity where you have these tiny little ports. You have to make sure that each of those cables are going into them correctly. And they were able to train a model that actually understood 99% of each of those 7 steps. And then from there, that was able to reduce labor costs by 7% and improve their defect rate by 67%. Another example is Stanley Black & Decker. So they used one of our partners, our ISV partners called DPOW, and they've used VSS to build a video training assistant, and that has actually been able to help reduce training costs at Stanley Black & Decker by 54%. It's created a video training assistant, which runs through the different processes of how to use equipment. It helps to troubleshoot when operators might have run into a specific error and point them to a specific place within the video so that it really saves time and removes the need where they were often looking through lots of documentation, trying to look in a video. So instead of watching an hour of video, they can just go and pinpoint the exact spot within the training video that addresses their specific need. And so how do you actually bring all of these AI agents down to the edge? We have a portfolio of embedded devices called NVIDIA Jetson. It's a family of computing platforms that can really take AI and its capabilities down to the edge devices. and it's really high performant and power efficient, and has been used. And so here you'll see, based on different configurations to suit different types of use cases. And in order to do that, so the previous blueprint that I showed you was for video search and summarization. That one has RAG components, it's got lots of different models, but edge devices, because of the smaller footprint, you may have to simplify and optimize the blueprint or the types of AI that you have running for your visual AI agent. And so we have 3 different workflows that are available that are specifically created to run on NVIDIA Jetson type of devices. So there's one for object detection. There's one here that you can see that's more of an alerting Q&A type of interaction. And the last one is really focused on object detection. So all of these reference workflows are available on GitHub. And we're really excited about how we're also working with AWS. So AWS actually offers something called the Connected Edge Intelligence. And what this does is actually work and manage all of the edge devices. It helps to train all of the models that you might be having to deploy when you build these visual AI agents on the edge devices. And it will actually work as a control plane, an orchestrator for all of those devices. And so it uses a component called IoT Greengrass. It's a cloud service that will manage all of the AI in the cloud and then deploy them onto your edge device. So you can actually see this all in action in a kiosk back on number 30 behind this stage. So the last AI agent that we have is really at the macro level. So this is when you're not looking to just do visual inspection on a certain product or a task. You're not doing it at a process level. You're really elevating it to look at how do you actually automate across an entire space or an entire facility. And so that is often very difficult to do because it's such a large space. And what it requires is an understanding of the full facility, the understanding of all of the different objects that are and people that are moving within your facility and how they work together. And so NVIDIA has a blueprint called Mega. It's an NVIDIA Omniverse blueprint, and it integrates a digital twin together with some of the capabilities that you saw before with the VSS, as well as robotics, in order to simulate and optimize how robotic fleets can work within a facility. And so all of that is used to improve efficiency and yield production yields, and make sure that everybody operating within the facility is safe. So here's a demo, and we'll take it from there.
The supply chain solution company, Accenture, a global leader in professional services, and NVIDIA are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an NVIDIA Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their omniverse digital twin environment, planning their next motion and acting. The robot brains can see the resulting state through sensor simulations and decide their next action. The loop continues while Mega precisely tracks the state of everything in the digital twin. Now, Keon can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Keon and Accenture are reinventing industrial autonomy.
So I kind of ran through the mini, the micro, the macro types of AI agents that you can build. And what you saw with Mega is that's really at the macro level. There's a lot of work involved because you need to create a digital twin. But at that point, you're really looking to optimize your entire factory. But these mini, micro, and macro AI agents are really a way to think about it, so you can also see how you can crawl, walk, run with us in terms of how you engage and figure out how you want to deploy AI agents within your facilities. If you want to learn more, we have demos of the visual inspection as well as the visual search and summarization agents. It's on kiosk 30, tucked right behind the stage. And if you want to try this out in the cloud, you can start, just register for VSS, or that video search and summarization blueprint. It's in early access currently, and you can deploy that, utilize your own videos, and start testing. And if you wanted to try it on the edge, we have a link that will take you to a variety of reference workflows so that you could start building those AI agents on the edge. All right. Thank you. Do we have any questions? So we know that working together and really building the next area of industrial digitization takes a lot of work and partners working together. And so NVIDIA is working not only with AWS, but together also with Siemens. And Siemens will actually be doing the next presentation. So I welcome you and hope you all stay also to hear how Siemens is working together with AWS and NVIDIA on doing AI physics simulation, as well as some of the other things that are listed up there. Thanks so much.